Hello, I am Dr. Michael McEllin. I spent 40 years using computers to calculate the physics of nuclear reactors. Now I've retired, I use my mathematical and computing skills to do digital art. I want to talk to you about a project which will allow you to become creative using computers. It would be suitable for submission as a Silvercrest project, or else developed to a higher level of sophistication also for a Goldcrest project. In fact, quite a few famous artists, going right back to the Renaissance, have been inspired by mathematical ideas. These are a couple of relatively modern examples. Sir Christopher Wren, who designed these buildings, was also the Professor of Astronomy at Oxford. In fact, the monument was initially designed with a dual purpose as an astronomical telescope pointing straight up at the sky. So, being artistically inclined does not mean that you can't know about science or maths, and being creative does not prevent you being a scientist or an engineer. In fact, I think that learning to exercise your creativity makes you a better scientist or engineer. There are now even quite a few university degrees at prestigious institutions that teach creative computing, and their graduates are welcomed into some of the most interesting jobs around. We are going to start simple, just taking a line for a walk. We will find that a surprisingly simple program can produce quite a lot of art. But after you have mastered this basic technique, there are many other possibilities. Some are explored on my Artful Computing website. You will get the address, along with further instructions for this project at the end of this video. We are going to use a tool called processing that you will have to download and install on your computer. It is free and widely used in creative computing. It is also well supported by tutorials. If you get hooked and want to do more advanced stuff, there are many excellent, visually exciting books full of good ideas and techniques. You will also find plenty of creative computing support groups on places like Facebook, and lots of examples of digital art on Instagram and other online galleries if you search for terms like creative coding, generative design, mathematical art, and so on. Processing is good for producing animations. We start with drawing a simple line. Then we let time run and we move the starting point of the line around the screen, and also let the line rotate as it does so. We might also choose to vary the colour of the line as time goes on. At any point, we might choose to save a copy of what we see on the screen, though you will have to work out how to do this yourself by reading the online reference. Here are just a few examples that I produced myself. You can get an extremely wide variety of images from just one simple program by changing the recipe just slightly each time. You can even replace the straight line with a wavy line and give it a slightly wavy colour, and perhaps make it transparent, and suddenly a whole new range of possibilities are opened. Where you take this is limited only by your visual imagination. Having mastered that, we can move on to something just a little more complicated. How many of you remember playing with one of these spirograph toys? Although they first appeared over 50 years ago, they still sell well. I suggest you work out how to produce a processing program that produces the same type of diagrams. This toy is based on the mathematical idea of epicycles, rolling one circle around another. You will need some of your basic GCSE trigonometry for this challenge, but really only the most basic stuff. This might take you perhaps twice as much code as the previous exercise, and more if you want to add your own ideas, such as changing shapes and colours while you are drawing the curves. It still ought to be a relatively small program, somewhere between 100 and 200 lines of code in processing. These are some examples of images that I created with my epicycle program. You could just follow the evolution of the epicycle curve as you would with spirograph. However, with the computer, we can decorate the curve at each step and play with the colours as we move. Let your imagination suggest new possibilities. I have placed a written project brief on my website, where you will also find other useful information for the project, along with examples of a much wider variety of techniques and associated image galleries. Although most of the things I do require no more than A-level maths, I occasionally call on my university mathematical training to try out more complicated ideas. But often it is the simplest things that work best. Remember, where you take this is up to you.